Okay, so the problem is given 3 points on a parabola. What is the equation of the parabola in the conic section vertex form? And given 3 points, we really don't know a ton about it, but we do know that every parabola takes the form y equals ax squared plus bx plus c form. And what we don't know is we don't know the a, b, or c value, but we do have 3 sets of x's and y's that we're going to plug in to the equation, and we can set up a system from there, which we can actually use a fancy way of solving it. So I'm going to plug 14 in for the y, and I'm going to plug -1 in for the x. So it's a times -1 squared, which is 1, plus b times -1 plus c. And then I'm going to plug 5 in for the y, and I get a times 5 squared, which is 25, plus b times, oops, I got that wrong. Let's go back. A times the x squared value, which is 4, plus b times the x value, which is 2, plus c. And then I'm going to plug in 14 for the y. I'm on my last point. A times 3 squared, which is 9, plus b times 3 plus c. And that will get us to a set of equations that look like this. 14 equals a minus b plus c. 5 equals 4a plus 2b plus c. And 14 equals 9a plus 3b plus c. And if we want to solve this set of equations out so that we figure out what a, b, and c are, we're going to use a system on our graphing calculator. So I'm going to go back to my graphing calculator, and I'm going to use a matrix. So I'm going to go to second, matrix. Oops. Clear that off. Second, matrix. I'm going to edit A. A is going to be a 3 by 3. And I'm going to enter the coefficients from these. So I'm going to enter 1, -1, 1. I'm going to enter 4, 2, and 1, 4, 2, and 1. And I'm going to enter 9, 3, and 1. That'll be matrix A. I'm going to quit. I'll go to matrix B, and we'll edit matrix B. Matrix B will be a 3 by 1. And I'm going to use these values for matrix B. 14, 5, and 14. And the way we get our answer for the system from our matrix chapter is we take matrix A to the -1 times matrix B. And what we should get out of that are our coefficients, our A, our B, and our C. So it turns out A is 3. A is 3, B is -6, and C is 5. Now what this all allows us to do is it allows us to write a general form of the equation, not in vertex form, but a general form of this equation of 3x squared for the A minus 6x plus 5. That is a standard form, not the vertex form, not the conic section form that we actually want in this chapter. So I'm going to go ahead and complete the square like I would have in this chapter. So I'm going to isolate the 3x squared and the 6x. I'm going to bring the 5 over to the other side. So I'll write it as, I'll minus the 5 here, and I'll go 3x squared minus 6x. I'm going to need a blank here, equals y minus 5. I'm going to divide everything by 3. I get x squared minus 2x equals 1/3 of y minus 5/3. I'm going to put a blank here and a blank here on the end. What goes in the first blank is half the 2 value, half the -2 is 1, 1 squared is 1. So I'm adding 1 there, and I will add 1 in this spot also. That makes this a perfect square trinomial. X minus 1 squared equals 1/3 of y, and 1 is actually 3/3. So I take -5/3 plus 3/3, and I get a -2/3. Almost there. X minus 1 squared equals, I'm going to factor 1/3 out, and I'm left with y, and then if I factor 1/3 out of -2/3, I'm left with y minus 2. That is the conic section form of the equation. The one up here was the standard form of the equation, and there's kind of a cool way to check this. You can go to Desmos and you can enter both equations. One I've already done. You notice y equals 3x squared minus 6x plus 5, and you can enter the other equation, x minus 1 squared, parentheses x minus 1 squared equals, and because it's Desmos, I don't have to have it in y equals form, which is really nice. 1 divided by 3, parentheses, and it's y minus 2. And if I've done it right, the two graphs should appear right on top of each other. So an easy way to check to see if you've completed the square right there, is to put the second vertex form in there, and they should be right on top of each other, and you can see that they are. Furthermore, we could actually go in and we could make sure that these points were on the graph. We need to make sure -114 was on the graph. So I can actually like trace, ooh, there's -114 right there. Look, that's on the graph. 2, 5 is on the graph, right there's 2, 5. And then up here, what was it? 314 is on the graph, and there's 314. So we can further use Desmos just to make sure that we have the right problems, right? The right equations.